Hi guys, my name is JJ Khoza. We are proceeding with our lectures. Our previous lecture was about linear equations. Yeah, we did linear equations and we explored all possible problems that one could find with linear equations. We saw what is it that we do when we have coefficients that are fractions, because most of the people have a problem when the coefficient is a fraction. So we dealt with that. Now, I am doing exciting work today. We're starting quadratic equations. Quadratic equations are very important, and there are many different forms of quadratic equations that we are going to talk about today. They come in different forms. It's unlike your linear equations. So quadratic equations, they have a general form. So let me just write a general form for a quadratic equation. Quadratic equation. Quadratic equation. It has a general form. General form. Which is ax, I'll write it in red, ax squared plus bx plus c. That's it. This is how you identify a quadratic equation. It's important to be able to identify a quadratic equation. I'm sure you know me by now. I like to do things in an orderly way. I follow the rules of mathematics. I actually enjoy them because they remove all the confusions that one may have in his or her mind. They are very good. They enable us to follow a logic. They are logical. So, I'm a man of rules. Rules for solving quadratics. So I'll just write rules. You know what I mean. The rules. Okay. Yeah. All right. Yeah, my pen. Okay. The rules. There are 3 rules. When we were working with linear equations, I also spoke about the rules. When we were working with algebraic expressions, I spoke about the rules. And now, I'm talking about the rules for solving a quadratic equation. Let us start. So, rule number 1, we have to make this equation homogeneous. I forgot here, equation. I remember now when I'm saying equation. An equation is characterized by having an equal sign. Okay. Rule number 1. The equation, the quadratic equation, it must be equal to 0. So you decide that you make right hand side equal to 0 or left hand side equal to 0. I like right hand side equal to 0 because when we read from left to right. When I come to a solution, variables will be on the left hand side, so I'll be able to read x equal to something other than having a number equal to x. Still right, but to me it just doesn't feel right. I like to have 0 on the right hand side. Number 2, you have to factorize. We find factors. We have to factorize the quadratic. We did speak about this in one of our lectures, I think is part 5, where we spoke about factorization. It was factorization of difference of two squares, trinomial, and difference of cubes. So you factorize this doesn't look neat. Number 3, wow, this does not look like a 3. Good. All right, there you go. Okay, after factorizing, solve for x. Okay, factorize. This factorize does not seem clear. Let me make it look neater. Factorize. That's it. I'm going to do example number 1. Example number 1, I'm using a difference of two squares. Let me take the most popular one, minus 16 equal to 0. Now we have to express this properly in a form of difference of two squares. X is clear. X is x squared. Everybody can see. But 16 is not clear. So I'm going to make it 4 to the power 2 equal to 0. And then I'm going to open the brackets. I'm no longer going to explain much here because we did talk about factorization. Minus 4. Because it's a difference of two squares, we're going to have alternate signs. The signs is going to be positive or negative. It does not matter which side you put it on. And then This bracket means something. I'll show you now the meaning of this bracket. So I'm taking x minus 4 equal to 0, or these brackets here, it means or. We bring back this one. And then we do transposition. 4 does not change sign on the other side. We have to correct that error. 4 does not change sign on the other side. It does not become positive. That is wrong. We do a transposition. We do not want this 4 on the left hand side. It is positive. What do? We do an opposite action of what the 4 does currently. So here we have a negative 4. In order to get rid of it, we have to use a similar thing with an opposite sign. Another 4 with an opposite sign, which is positive. Therefore, we are going to have negative 4 plus 4. Remember the rules of equality. What you do on the left hand side, you do on the right hand side. So on the 0, we are going to have 0 plus 4. This gives us x equal to 4. I hope you are clear. Even here, let me just do this. Plus 4 subtract 4 equal to 0 subtract 4. X is equals to negative 4. That's it. This is example number 1. We may have also another case. Example number 2. Example number 2 is where we are required to take out a common factor. So we're having x squared minus 4x equal to 0. We are looking for the highest common factor. Highest common factor. And this highest common factor is x into x squared minus 4 equal to 0. Remember, I said, because when you're having this, it means you also have a bracket here. So because we have a bracket here, it means or. You must remember that. Immediately, x is equals to 0, or x minus 4 is equal to 0. Sorry. Let us correct this mistake. Okay. X minus 4 equal to 0. Taking out a common factor here. I did explain on the previous lecture that taking out a common factor is actually dividing by that factor, or that particular variable, or the number. Does not matter what it is, as long as you know the definition of a factor. I think you still do. X is equal to 0, or x is equals to 4. So I'm no longer explaining here because we've covered this section. And then we are going to have a third example. On the third example, we are doing a factorization of a trinomial. We dealt with a trinomial. When we factorize a trinomial, we are looking for the factors of a trinomial. Now, example 3, we have negative 5x squared minus 5x plus 30 equal to 0. Okay, what's the first thing that I need to do here? We need to get highest common factor. And what is it? A number that can divide throughout. What is it? The highest. 5 can divide a 5, and 5 can divide this 5, and 5 can divide here. So I'm going to take out a negative 5. Negative 5. Negative 5. Into x squared plus, remember, negative divided by a negative is positive, minus 6 equal to 0. Do you want to divide by negative 5 both sides? Yes, you're going to get a 0, right? Oh, you'll divide by negative 5, divide by negative 5. 0 divided by negative 5, you're going to get a 0. We end up with x squared plus x minus 6 equal to 0. We have to factorize this. Okay. When we factorize, we have this factor of x here. And the trick is to find the factors of 6 that when we add or subtract, they will give us the value of the middle term. The factors of 6 are 1 times 6, multiple factors, and 2 times 3, 3 times 2, and 6 times 1. Because we did this before, I'm going to subtract 3 and 2. 3 subtract 2. I'm going to use this combination, because if I say 3 subtract 2, I get 1, and this is what I'm looking for. There is a 1 here. I'm going to use this combination. This combination, 3 is positive and 2 is negative. Right. X plus 3 equal to 0, or x minus 2 equal to 0. X is equal to negative 3, or x is equal to positive 2. Right. What if we have the first term with a larger exponent? Maybe the first term is to the power 3, is a cubic. What do? We still solve it. We're not scared. The reason why we're not scared, we work by the rules. So I'm not scared at all. I've got this problem, x cubed subtract 2x plus x equal to 0. I'm not going to finish it because it looks exactly as this one. There's something that I just want to show you. On this one, I'm also going to apply the same method here. We're going to look for the HCF. In this instance, the HCF is going to be a variable because we've got variables throughout. So that variable is x. Let me make it red. Okay. So we have x squared minus 2x plus 1 equal to 0. X equal to 0, or x squared minus 2x plus 1 equal to 0. Then you're going to factorize this and find the answer. And the answer that you are going to get here is going to be x equal to 1. You must work it out, you'll see. And you are also going to get x equal to 0. Alright, I want you to find these vectors. You must fill in. I think we've covered problematic ones. The next to come, you remember we did fractional expressions, fractional algebraic expressions. Now we have fractional algebraic expressions that are in form of a quadratic. Remember we did the equations, fractional equations, linear. I showed you how to work it. We apply the same principle. Let me give you this. By the way, this was example 4. So example 5. I'm just showing you. I'm not going to solve this because we've been doing these things quite a long time. 1 over x plus 1, it is equal to 1 subtract 2x over x minus 1. What are you going to do here? We are going to look for the denominator, a common denominator. What is the common denominator here? The lowest common denominator is x plus 1, x minus 1. Remember, you can do what you want. You must apply those rules. At the end of the day here, you are going to end up with a quadratic because 2x is going to multiply possibly x plus 1, and then you are going to end up with a quadratic. That is what is going to happen because you are going to multiply both sides by x plus 1 and x minus 1. You multiply both sides of the equations. And therefore the LCD, let me just write it for you. LCD is x plus 1 x minus 1. So you will take this and multiply this term, and that term. You resolve it. I'm not going to do it. We've been working on these things over and over again, over and over. I'm proceeding. I want to do new things. We have dealt with those equations. Sometimes you find that these quadratic equations look rather complicated or too much to do. Let us take this example. Equations, these are special ones. Equations with substitution. K method. K method. We are going to use K method. Here you find that there is a term that is repeated. It will look like this. Let me just take this example. X minus 2, x minus 3x all squared minus 8 into x minus 3x minus 20 equal to 0. You can solve this, but it's just too clumsy. As I said before, in mathematics, what is it that we do? We simplify things. So we can simplify this one too. I forgot, I must put this. So this is the reason why it is called a K method. Why it's called a K method is because we're taking this term x squared minus 3x, we equate it to k. What happens when it's equated to k? It means we are going to substitute k. We substitute k into the original equation. In place of x squared, in place of x squared minus 3, we are going to write k. So it's k squared minus 8k minus 20 equal to 0. And you factorize. I taught you how to find the factors. K, K. There's got to be a 10 and a 2, so that when I multiply I get a negative, and I can subtract. I can get, so that when I do the subtraction or addition I get a negative 8. This will enable me to get that. Therefore k is equals to 10, or k is equals to negative 2. This is not all. Remember, we have x squared minus 3. Let me write it in red. We have x squared minus 3x equal to 10. So we have x squared minus 3x minus 10 equal to 0. You solve for this equation. You find answers. You do the same, or x squared minus 3x is equal to negative 2. X squared minus 3x plus 2 is equal to 0. You are going to factorize. You have x, you have negative 2 and negative 1, so that when they add up they give you get x is equals to 2 or x is equals to 1. This is for you to solve. I wanted to show you the K method, and we are done with it. even if it comes in a form of a fraction. Let me show you. I'm going to write it in a different pen, purple. Yeah, it's dark enough, you can see. Right. So you may have a problem of this nature. X squared minus 4x equal to 17 minus 60 over x squared minus 4x. So you can see this x squared minus 4x can be equated to k. And then you are going to have k is equals to 17 minus 60 over k. You multiply with k both sides, you end up with k squared equals to 17k minus 60, and you end up with k squared minus 17k plus 60 equal to 0. Then you factorize. I'm not going to do that. All I wanted to show you is that you have repeated terms. These repeated terms, this is what you search for. You equate it to k. Alright. We proceed. Sometimes you'll find that there is a need to do things like this. You may also find a problem that has got a combination of these things. We also find equations with sets. I'm going to write a set equation. A set equation. A set equation. Let me bring the S closer so that it looks like a word. Okay, fine. It's still far. That's it. Set equation. On the set equation we have steps, rules. Let me write rules. I like rules. Number 1, isolate the set. We isolate the set. Rule number 2, we square both sides. Three, we solve for x. Three steps. Here is an example. We have 2x plus 8 minus x equal to 0. This is under Okay. You wanna make me, let me make this clear. Yeah, that's it. Rule number 1, isolate it. What does it mean? I'll keep it on the left side. I'm going to have x this side. Step number 2, I square. I'll find 2x plus 8 is equals to x squared. What happened here? When you have, let me write in when you have 2x plus 8 all to the power half. You remember the exponents. So when you square it, this is a power of a power. You have to multiply the exponents. You have 1 over 2 multiplied by 2 over 1. 2x plus 8 power 1. So that is why it comes like this. And then you transpose this. I like to take this to the right hand side. There's a reason why. I just feel like doing that. So here is going to be 0x squared minus 2x minus 8. It's just simple for me this way. Otherwise you could have taken x and you'd have negative x on the left hand side, and you take a common factor of -1, then you'll then get it in this form. And then here you are going to factorize. You know, I'm not going to do it. I'm tired of factorizing. Alright. We come to the to the end of this. There is something that we cannot say we are finished when we have not done it. What is it? It is called completing a square. Completing a square to find the turning points and to derive the equation, the quadratic equation. I'm going to do that on the next lecture. Or should I do it now? Let's go. Let's go. We're starting something new now. Completing the square. Completing the square. When we complete the square, we are going to derive the equation, the quadratic formula, the one that we use to solve for x, when the equation cannot be factorized anymore. You get to that point where you cannot factorize a quadratic equation. You use the quadratic formula. As you go higher, you get to a point whereby you cannot use a quadratic equation. Maybe you have to use bisection method. There is one of these numerical methods that are used. For instance, Newton methods to solve quadratic equations. We use force there. Okay. Now, there are two things that we get. One, derivation of the equation to find turning points. Turning points, I'm going to call them TP. TP. I will explain that. Number 2, still the derivation of the quadratic formula. This is what we are going to do. Just these two things. And I will show you in a general form so that you'll be able to apply it on your own. I will not use examples here. We have, so for example number 1, let me make it thicker. 1. To find turning points, right? The equation that assists us to get turning points is represented by y is equals to a into x plus or minus p all squared plus q. This is what we want to do. We want to arrive at this level because a TP, a turning point, is a turning point in a Cartesian plane. It's P map Q. Generally, we know we use X map Y in a Cartesian plane. So P represents the value of X in the Cartesian plane, and Q represents value of Y in the Cartesian plane. Now we take the general form. We have ax squared equal to 0. What do we do? I divide by a throughout. So when I divide by a, I'm going to have okay, let me just stop right here. So when I divide by a, or I need to find, I nearly started somewhere. I nearly derived a quadratic equation. I'm so used to start with it. So we have a general form in the form of y is equals to ax squared plus bx plus c. Alright. I'm still going to do the same thing. I'm still going to take out the common factor, HCF, highest common factor. Now, it's a. Plus b over a x plus c over a. Right. Now what do? We've taken we've taken out the common factor a. What's the next step? The next step, we are going to half the middle term and square it. X squared plus b over ax plus b over 2a all squared, we add it, plus c over a, and then we subtract b over 2a. Okay, let me do this. Squared. And then y is equal to a. What are we doing here? X squared plus this term will fall off, this one, it falls off. We are left with b over 2a all squared plus c over a minus b squared over 4a squared. And then here we group this. They are both squares. We group them plus b over 2a all squared plus c over a minus b squared over 4a squared. This is what we want. This is it. Let us make let b over 2a equals to p, and c over a minus b squared over 4a squared equal to q. Therefore, finally, we have a into x. It could be a plus or a minus, plus p or subtract p all squared, plus q. This is a general form. Alright. To do the quadratic formula then is easy, because in the quadratic formula we apply the same principles as we have done. The difference is that the equation is equal to 0 and we are solving for x. Quadratic formula. This is a quadratic formula. A quadratic formula, general form, quadratic equation, I mean, general form here. Alright. We are going to divide by a throughout. We have plus b over a x plus c over a equal to 0. X squared plus b over a x plus b over 2a all squared, I did explain this, equal to negative c over a plus, now we add it, we add this term here. Okay, so now we are left with, we group the like, and I've already taught you guys how to work with expressions, these ones, algebraic expressions, and also to work with fractions. So I'm just going to do the whole thing here, negative 4ac plus b squared all over 4a squared. Remember, I taught you to work with fractions, so I'm not going to go back and explain what happened here. Right now we are not dealing with that part. We're dealing with the process of completing a square in order to derive a quadratic formula. Now, both sides, let me rearrange this. B squared minus 4ac over 4a squared. here we have x plus b over 2a all squared. Square root, we get x plus b over 2a equal to b squared minus 4ac, still under the square root, over 2a. The square root of 4a squared is 2a. And then we transpose this term. We transpose this. We end up with negative b plus minus, here we got, I forgot to write this, okay, here we have b squared minus 4ac all over 2a. This is what we've been looking for. We are done. We are done. Make sure you understand this process and that process. It's actually the same thing, exactly the same thing. We use this to solve for x when we can no longer factorize the quadratic equation. We apply this. Alright. We're also going to talk more about the nature of roots when we are analyzing the answers, the solutions that we get here using a quadratic formula. Okay guys, now we are done with this lesson. Please like my video, please, and moreover subscribe to my videos, subscribe to my channel, so that each and every video that I upload you can receive it. And thank you very much for those who are subscribing, and spread this word. You know, we've got to spread these videos to all learners of mathematics so that they can get a better understanding. Mathematics grows from step 1, 2, 3 up. You need the fundamentals. I've done fundamentals. I hope now you can see things are starting to change. Here you're having a bit of everything that we've discussed. It's here. It gets more and more complex, more and more complex. You will not see the complexity as a difficulty if you have the foundations and you know the rules, the properties, the laws, fundamentals. You'll never go wrong. Subscribe to my page. Subscribe to my video. Thank you guys. Bye bye.